Good morning, everyone. I am Krisha Mange, and today I'll be speaking about an exciting topic from theory to practice implementing the data structures in Python. So, this is my presentation which I will be talking about. When we first hear the words data structures and algorithm, it might sound technical or even a little intimidating. But when we start applying these concepts through a language like Python, they become logical, visual, and even fun. Python turns theory into something practical, helping us understand how data can be organized, stored, and used efficiently in real problems. Now, what are data structures? Data structures are basically different ways of organizing and storing the data so that it can be accessed and modified efficiently. Think of them as different types of containers, each designed for a specific purpose. Some are fast when it comes to searching, some are better at adding or removing the data, and others are idle for connecting related information. In programming, choosing the right data structure can completely change how efficient and powerful your code becomes. Common data structures and their Python implementation. The first structure is array. In Python, arrays are represented using list, which allows quick access to elements by their index. This is the example of the array. Arrays are perfect when you know exactly where your data is located. They are used for tasks like storing scores, managing records, or maintaining an ordered list of the items. They provide simplicity, speed, and easy indexing. Next comes the stack, which works on the principle of LIFO, that is last in, first out, meaning the last element added is the first one to be removed. It's like a stack of plates. The one you place last is the one you pick up first. This is the example of the stack. Stacks are extremely useful in real-world scenarios such as managing the browser history, undo operations in software, or even function call management during the program execution. Now moving on to the queues, which follows the first in first out principle. In Python, they can be implemented using the dequeue class from the collection module. This is the example of the queue. Queues are ideal for handling the processes that must occur in order, like print jobs, customer service requests, or scheduling the task in an operating system. They ensure fairness and smooth execution, one task at a time. The next data structure is linked list. Unlike arrays, linked lists are dynamic. They can grow or shrink as needed. Each element or node contains data and a reference to the next node. This is the simple program of linked list. So linked lists are excellent when you need flexible memory usage, such as when elements are frequently inserted or removed. They are used in systems where data keeps on changing in the real time, like in playlist or the task manager. Now let's look at trees, one of the most powerful and widely used data structure. A tree represents data hierarchically. Each node can have one or more child nodes. This is the example of the tree. So trees are used everywhere, from organizing the files on your computer to representing the hierarchical data like company structure, family trees, and even in the artificial intelligence for the decision making. Now we will see the real world applications. So this traditional data structures plays an essential role in solving the real world problems efficiently. Arrays are used in storing list, student data, or inventory information. Stacks handle undo redo operations and backtracking. Queues manages task, request, or message processing system. Linked lists are used in dynamic memory applications and smooth data handling. Trees organize hierarchical data and power advanced algorithms like searching and sorting. Understanding this structure allows programmers to design systems that are faster, smarter, and more reliable. So the conclusion is that Python makes learning and implementing the data structure easier than ever. Its clear syntax allows us to visualize and apply the DSA concepts directly, bridging the gap between the theory and the practical application. Data structures are not just a part of the syllabus, they are the building blocks of every modern software we use today. Thank you.